Hello Year 10 and welcome to today's lesson. We're back to our pre-recorded content and should be having alternating live lessons and pre-recorded lessons for the next couple of weeks. In our pre-recorded sessions, we're going to continue looking at algebra. Please make sure that if you are struggling, you are pausing the video, rewinding, re-listening to those explanations that I'm giving. Don't forget you have access to lots and lots of other places where you can get extra help. Heggerty is great for extra explanations as well as alternative. Heggerty may explain things slightly different to me. Heggerty will also give you access to lots and lots of quizzes so you can practice these skills over and over and over again. Corbett Maths is another good place to look. Here's a few videos on there. Alternatively, in your journal, you do also have your maths methods booklet, so you can have a look at that and that will also give you some hints and tips. In today's session, we're going to continue looking at simultaneous equations. We're on to our second lesson now, and there will be a couple more on this next week. To start today's lesson, can you please pause this video and have a go at the do now? Welcome back. Now you'll notice that I keep asking you to practice these factorising skills. We've briefly stopped looking at quadratics at the moment, and we're looking at linear expressions. However, we are going to come back round to quadratics. We're going to start looking at simultaneous equations next week with quadratics involved. And at that point, you are going to have to start being really clear on your factorising skills. If you can't factorise, you're going to really struggle. So do recommend that you really give these questions a good go and do nows. And that you also do some extra work around your home learning to see if you can improve these skills at all. So for question 1, I want two numbers that multiply to give me 5 and add to give me 6. The only two numbers that multiply to give me 5 are 1 and 5, and luckily those add up to give me 6. That's going to give me x plus 1, x plus 5. For the one on the right, I want two numbers that multiply to give me 20 and add to give me 9. Factors of 20, I could have 1 and 20. I could have 2 and 10. I could have 4 and 5. And I'm going to stop there because 4 and 5 will add up to give me 9. So it's x plus 4, x plus 5. For this one down here, I want two numbers that multiply to give me negative 9 and add to give me negative 8. Those signs are important. For numbers that multiply to give me a negative number, one has to be positive, one has to be negative. So for 9, we could have negative 3 and positive 3. We could have 1 and negative 8. We could have negative 1 and, it should be 9. And 9. Okay, I'm getting my numbers confused today. Now if I stop here, I notice that if I have 1 and I add negative 9, it's going to give me negative 8. So the pair of numbers I want are these two. So I'm going to get x plus 1, x minus 9. For question 4, I'm going to zoom in. Now, it's been a while since I've explained one of these to you. We looked at these way back at the beginning when we were first looking at factorising, and they are a little bit more complex. There's a few steps you need to follow. The method we use is called the AC method because it involves multiplying the x squared coefficient, which is referred to as a, times the plus c on the end. So if I take a is equal to 2 and c is equal to 3 and I find AC, well that's a multiplication, and it gives me that AC is equal to 6. Up next I want factors of 6, so numbers that multiply to give me 6, that add to give me b, that's the number next to the x, coefficient of x. Factors of 6 could be 3 and 2, and they do in fact add to give me 5. Up next, I want to rewrite this equation with b split into these two terms. I'm going to have 3x and 2x. Well, actually, I'm going to choose to write 2x and then 3x. It doesn't really matter which way around you do. I just choose to put the 2x first because that's nicer next to the 2x squared because that's nicer to factorise. It doesn't make any difference later. It's just a preference. So I'm going to have 2x squared plus 2x plus 3x plus 3. I then want to factorise in 2 halves. From each of these two terms, I can factorise out 2x, which leaves me with here, I get x. And over here, I just get plus 1. 2x times 1 will give me 2x. For the one on the right, I can factorise out 3 here and also 3 here. So I'm going to get 3 and then x plus 1. 1 times 3 will give me 3 here. Finally, I need to write into 2 brackets. Because this bracket is the same, that creates one of them. Then my other bracket is everything left over. I've got 2x and plus 3. Now that is quite a tricky skill. On occasion you'll be asked to do that in an exam. But it is worthwhile learning because wherever you see a quadratic, this could come up every now and then. Okay, so I'm going to zoom out so you can see all of your answers there. Okay, so to start this lesson, can we please write down today's date and title? It should be the 27th for you. And also take a note of those keywords again. Okay, so last lesson in a pre-recorded session, we were looking at solving simultaneous equations. We're going to continue to look at that today. We're also going to continue to use what we call the elimination method. So I'm not going to be substituting one of these equations into the other. I'm going to choose to eliminate. Now, last lesson, you saw lots of things that look like this. And we noticed that when we added these up, these two would cancel out. Okay. Alternatively, it might have been the x. And the key thing with these questions is the ones that cancel, there was always the same number of. So you might have had positive 2y and negative 2y. They cancel each other out. You could have just had one of each. We could have had 7y and negative 7y, and they would cancel each other out. We could also solve them if instead they were both positive. This equal to number and this equal to number. If they were both positive, I could subtract. So where the sign was different, I added them up. Where the sign was the same, we subtracted. And this also worked even if these two signs here were negative. So for example, 2x minus 3y and 4x minus 3y. Okay, even where those signs were negative, if they were the same, we could subtract. Because if I take negative 3y, then I subtract negative 3y. This instead becomes plus, and they cancel each other out. This is what we looked at last lesson, where when you were eliminating one, they already had the same number. One might be positive and negative, they might both be positive, they might both be negative, but they cancel each other out quite nicely. What you're going to see in today's lesson is that instead, they're not all cancelled, they won't all cancel instantly. If I was just to say add these up because they're different signs, if I add them up, I get 17x, negative 2y plus y, well that creates negative y, 8 plus 18 is going to give me 26. Well, that doesn't help me because I now can't solve this because I've still got two unknowns. So I can't just immediately add them up. I need to do something else. What we're going to do is force one of these equations to look similar to the other one. I'm going to choose to use this second equation. So I've got my first equation and my second equation. Now, it doesn't really matter which way around you label them. I just refer to them this way so you know which one I'm talking about. In my first equation, I have negative 2y. In my second equation, I have just 1y. I want to make this 2y. Now, the way to do that is if I multiply this entire equation by 2, so if I take equation 2 and I multiply it by 2, well, that's going to give me 10x, 2y, and 36. Okay, all I've done is I've just doubled the equation. This has created equation 3. Now what you'll notice is if I was to just look at equation 1 and equation 3, we've got negative 2y and positive 2y. So if I was to add these equations now, they would cancel each other out. So that's what I'm going to do. I'm now going to rewrite equation 1 under here. This is equation 1. I haven't done anything to equation 1. I've just changed equation 2 to look like equation 3. They are exactly the same. It will still be the same value of x and the same value of y that creates 18 here, and they'll create 36 here. I've just doubled the whole thing. I can now add these up, which is going to give me 22x. The y's cancel, and then that is equal to 44. To find x, I want to divide by 22, which gives me that x is equal to 2. The only other thing I need to do now is substitute this back into one of the equations to work out y. I'm going to substitute into equation 2, just because I don't really fancy dealing with this negative here. So I've got 5x plus y is equal to 18. Substituting in x, I get 5 times 2 gives me 10, plus y gives me 18. This means I don't actually need to rearrange this one. I know that y must be 8. That's the only way that I will get 10 plus a number is equal to 18. And that there is your solution. So where they don't immediately cancel through additional subtraction, in this case it created I was left with negative y, we need to multiply one of those two equations to force one of them to have the same number of either y, it could even be x, we could force it to be the x, and then we can follow the same process as before. Please pause the video here and write this down as an example. And have a go at the one on the right. Okay, you've actually got a couple of options with the one on the right. Now, immediately, my first thought was to multiply the top one by 3. So I'd end up with negative 3y, and then I'd have positive 3y, and they'd cancel. You don't have to cancel the y's. You could, if you wanted to, cancel the x's. And actually, that's what I'm going to do, because to create the first one, to get the first one to have 4x, that they've both got 4x, I only need to multiply by 2. And multiplying by 2 is far easier than multiplying by 3. Not by much, but it's certainly preferable. So I'm going to label equation 1 and label equation 2. I'm going to take equation 1 and multiply it by 2. That creates 4x minus 2y equals 12. All I've done is I've doubled this term, and doubled this term. Just multiplied by 2. So this has created equation 3. I'm now going to take equation 2 and write that below. Okay, so in the first one I used equation 3 and 1. This time I'm going to use 3 and 2. It's absolutely fine. These two have the same sign, so I want to subtract. So I want to do 4x, take away 4x, so I'm left with no x. Just be slightly careful here. Negative 2y, so I've got negative 2y, do some working outs down here. Subtract positive 3y, subtract positive 3y. Remember that when you subtract a positive number, it's just subtracting, so I've got negative 2y minus 3y. This is going to give me negative 5y. And on the right hand side, 12 take away 22 is going to give me negative 10. Now the first thing I want to do is realise that because both are negative, if I was to just multiply by negative 1, I get that 5y is equal to 10. So you can do that where both sides are completely negative. It would be the same if they were both positive. Dividing by 5 gives me y is equal to 2. Only thing I need to do is substitute this back in to one of my equations to work out what x is. I'm going to substitute into equation 1, so I get 2x minus y is equal to 6. 2x minus 2 is equal to 6. 2x is 8, so x is 4. If you're unclear on anything I've done there, I recommend that you rewind this video back to the beginning of the first example and watch those explanations again. Okay, but what if I look at my two equations and I think, okay, what can I multiply one of these by to get the same number of y's or even the same number of x's? Well, there isn't really a number I can multiply 3 by to make it into 2. And there isn't really a number I can multiply 2 by to get to 3, so that's not going to work. If I look at the y's, well, 3 times 3 will give me 9y, but I only want 8y, so that's going to be too much. Now, Yes, you could, if you really wanted to, multiply by a decimal. It's completely unnecessary though. Multiplying by decimals, you are likely to make mistakes. It's not hard to do, it's possible to do, but you are likely to make mistakes. So you want to find a different method. In the previous example, we just looked at multiplying one of those equations. We could multiply both. There's nothing stopping us. Okay, and if I multiply both, I can force them to cancel each other out. So I'm going to look at my x terms. If I was to turn 3 into 6, I would have to multiply this one by 2. To turn 2 into 6, I would have to multiply this one by 3. So if I multiply the first one by 2, that's going to create positive 6x here. And if I multiply the second one by 3, it's going to create positive 6x here. That means they will cancel. So this time what I'm going to do is equation 1, I'm going to multiply by 2. Equation 2, I'm going to multiply by 3. When I multiply equation 1 by 2, it's going to create equation 3, which is going to be 2 times 3x is 6x. 2 times 8y gives me 16y. 2 times 43 is going to give me 86. So I've created equation 3 there. I also need to multiply equation 2, which is going to create equation 4. 3 times 2x gives me 6x. 3 times 3y gives me 9y. And 3 times 24 will give me 72. Now that they have the same number of x's and they're both the same sign, we want to subtract. 6x minus 6x cancel each other out. 16y minus 9y is going to give me 7y. And 86 minus 72 is going to give me 14. Dividing by 7 to solve for y is therefore equal to 2. Still need to substitute back into an equation, and actually you could substitute this into equation 1, 2, 3 or 4. It really doesn't matter which one. I would suggest where this is a little bit more complicated because you're doing two lots of multiplication and then the additional subtraction, that you substitute it into one of them. So for example, equation 1, and find out what x is equal to. Then take both of those numbers and substitute them into this one here and see if they equal 24. If they don't, you know you've gone wrong somewhere and you need to take another look at what you've done. I'm going to substitute y into the second equation, just because they're slightly smaller numbers, a bit nicer to work with. So I get 2x plus 3y equals 24. 2x plus 3 times 2 is going to give me 6. That's equal to 24. 2x, if I subtract 6 from both sides, means it's equal to 18, and therefore x is equal to 9. As I said, I could now take both these numbers, substitute them into any of my other equations. If it works, then you know you've got it right. Okay, once you've written down the example, please have a go at the one on the right. Okay, if you take a look at what I've done, I again chose to multiply the first one by 3, second one by 2. Numbers are reversed this time, that's absolutely fine because I was opting to cancel out x. You could, if you wanted to, opt to cancel out y. If you were to do that, I'd have to do this one times 2 to make this one 10, and then this one multiplied by 5 to make this one 10. What you're looking for is the lowest common multiple of either the x's or the y's, and then using that to cancel. Okay, there are times though when you will be dealing with simultaneous equations and not realise that that's what you're doing. Okay, they will give you worded questions and they might ask you to write some simultaneous equations or just write some equations to express that. And then other times you'll actually be asked to solve those equations. So in this one, we have 2 people are queuing in the post office and they were both buying stamps. One person bought 10 second class stamps, that's an important piece of information, and 5 first class stamps, and the cost was £3.45. The other bought 8 second class, 10 first class, and it cost them £4.38. Now what we want to do with this question is, the question might go further and say, well, how much was each stamp? How much was a first class stamp? How much was a second class stamp? Now, you can use sort of logical reasoning to work this out. You could substitute a few different numbers in, see if they work. However, what we could do is just write 2 simultaneous equations and then we could solve them. So to do this, I'm going to say that second class stamps, I'm going to represent that as the letter S, S for second. And first class stamps, I'm going to use the letter F for first. Okay, so those are my 2 different variables. I don't know how much S is. I don't know how much one second class stamp is. I don't know how much one first class stamp is, but I know that a combination of these will create particular amounts of money because they've told me those up here. And I also know those combinations, what they are. So for the first person, they had 10 second class, so they had 10 lots of S, and they had 5 first class, so they also bought 5 first, and their total cost was £3.45. Okay, and that's an equation. I don't know how much S is, I don't know how much F is, but I know that 10 lots of S and 5 lots of F equal this amount. Now, if someone at this point was to go, okay, well, how much is one second class stamp? I actually can't tell them yet. But I have a second equation that I can work that out, and that's why they've given me an extra person's information. The second person had 8 second class and 10 first class, and their total was £4.83. Now, this question hasn't even asked me to write these, but they haven't asked me to solve it. They just want 2 equations. So I'm going to stop just there. If you were to solve it, just like with the other examples we've looked at today, you'll notice that these don't immediately cancel. You've got to multiply. The nice thing is 5f and 10f. Well, if I multiply 5f by 2, I get 10f, and then I can just cancel those out. So I'd only have to do one lot of multiplication in this one. I don't want you to solve it for now. I just want you to see where we got those 2 equations from. So I've represented the 2 different objects that were being bought as letters. You could use any letters. I could have used X and Y if I wanted to. I just used S and F because it makes it slightly easier to compare it to what we've written up here. And then I just wrote down 2 equations based on the information they told me. Please pause the video and write this example down. I would like you to write down the sentence and then also the workings that we did down below. Okay, see if you can have a go at the one on the right. Okay, that question confused me probably as much as it did for you. It's a tea room, not a team room. Okay, so in this example, we're at a local tea room. Okay, and we've got 2 different tables. One table has had 6 buns and 3 teas, and their bill came to £4.35. But another table had a lot more to eat. They had 11 buns and 7 teas, and that came to £8.80. Okay, I would always recommend that you underline those numbers. That's going to help you just focus on what they're having rather than all the extra information they've given you. So we're going to say that buns are equal to B and that teas are equal to T. The first table, we had 6 buns, so that's 6 lots of B, and 3 teas, so that's 3 lots of tea, and that came to £4.35. At the second table, they had 11 buns, so that's 11B. They had 7 teas, and that came to £8.80. And that's that. They might then ask you to go ahead and solve these, but for now, I just want you to get used to writing the questions down. Okay, so for the remainder of this lesson, I'd like you to go ahead and pause the video and have a go at these questions. If you do want to have a go at some of those questions where you are writing your own equations, can I please ask you to go have a look at Heggerty once you finish these questions? So if you whiz through these in about 10 minutes or so, make sure you're going to Heggerty and looking up some of those more challenging questions. Okay, you'll want to search for simultaneous equations and then just click through to find the right video where there's a bit more problem solving involved. But for the remainder of this lesson, I like to pause the video and answer these questions. And here are your answers. Okay, so you've made it to the end of today's lesson. Now, for those of you who have signed up for the UKMT challenge next week, I'm going to be sending you an email later with details on a live challenge preparation session that I'm running tomorrow after school. It will be at 3:15. It will be on Zoom. Okay, it will be with me. I will go through some of the challenging questions on the paper I gave you from last year that hopefully some of you have had a go at. And you'll also be able to ask me to go through any particular questions or just ask me general questions about the challenge if you want to. It is completely optional, but I do recommend it. And it'd be really nice preparation for the challenge. I want to see how many of you can get gold this year. I'm sure a fair few of you can. Have a lovely day, and I will talk to you next week in our next pre-recorded lesson.